Hi class, I wanted to make a video working out a typical homework question that involves combining multiple matrix operations like addition and multiplication, if possible. So let's take a look at an example where we're given two 2x2 matrices. A is the matrix 1, 2, 4, 7. B is the matrix -1, 0, 2, -4. And we're being asked here if it's possible to find parentheses A plus B close parentheses squared. So the first thing we need to notice is order of operations would tell us we need to know if we can add A and B together first. So notice here that A is a 2x2 matrix and so is B. And if you remember from your notes in our previous videos, if you are adding or subtracting two matrices, that's only possible if they have exactly the same size or dimensions. They're both 2x2, so we can in fact find A plus B. So that would be our first step here. And how do you add two matrices with the same dimensions? Well, if you have a 2x2 matrix A, which in this case is 1, 2, 4, and 7. Sorry, the ugly 4 there. Fix that a little bit. There we go. And you're adding that to a 2x2 matrix B with entries -1, 0, 2, -4. We should end up with the same size 2x2 matrix. And to do that, we simply add the entries with the same place entry. So entry 1, 1 with entry 1, 1 gives us the new entry 1, 1. First row, first column, first row, first column. So 1 plus -1 is 0. If this had been subtraction, we would have subtracted them instead. 2 plus 0. 2 plus 0 is not 0. 2 plus 0 is 2. Excuse me. Again, entry 2, 1 here, second row, first column of both of them added together would give us 4 plus 2, or 6. And entry 2, 2, which is your second row, second column. Added those entries together. 7 plus a -4 is a positive 3. So now we're going to be looking at that particular matrix, A plus B, and seeing if it's possible to square it. So to square a matrix means to multiply that matrix by itself. So what we're really asked to do here, if we want to take that matrix and square it, wouldn't that just mean take that matrix A plus B and multiply it by itself? Okay. So in this case, I would just copy and paste the result of matrix A plus B here twice. So I would really have 0, 2, 6, 3 times itself. 0, 2, 6, 3. And let's see if we remember, how do we multiply a 2x2 matrix by a 2x2 matrix? Is it possible, first of all? Well, unlike matrix addition, where they have to be the same size, that's not necessarily the requirement here. However, the requirement was that the inner orders had to match. So the inner order here needs to be the same. And they both are 2s, so that means it is possible. So good. But in order to do it, we need to notice what size we're going to get. We're going to get the size of the outer order, so this time 2x2. But if that had been a 3 and a 4, it could have been ending up being a 3x4 matrix. So that's possible, right? Okay. So 2x2 is going to be our outsized size. So I'm going to make a nice large version of that to have space here. 2x2 should be my answer. For the first entry, I'm going to make some slots here so we have some space. For my first entry here, I'll say E for entry 1, 1 if you will. That would be first row with the first column. So I would take my first row of the first matrix on the left with the first column of the second matrix. And what I do is I multiply 0 times 0, which is 0, and then I take 2 times 6, which is 12, and I add those together. So in other words, entry 1, 1 should be the number 12. That is correct. And then to continue that process, let's do another one here. Grab another color if I can. How about orange? See if that works. Let's get entry 1, 2. So we look at the first row of the matrix on the left and the second column of the matrix on the right. So that's going to be 0 times 2, which is 2, and 2 times 3, which is 6. Well, 2 plus 6, did I say that right? Let me make sure I'm looking at the right thing. 0 times 2 is not 2. That's my issue. My bad. You're probably thinking, Professor, you've lost your mind. Sorry about that, guys. 0 times 2 is 0, not 2. I was thinking of 1 for some reason. All right, so 0 times 2 is 0. 2 times 3 is 6. So 0 plus 6 is, in fact, 6. So entry 1, 2, first row, second column, is the number 6. Let me grab another color here. How about pink? Let's see if pink works. For this entry here, we'll call it entry 2, 1. So second row, first column. We're going to take our second row of the left matrix with our first column of the right matrix, and we'll get 6 times 0, which we'll do it correctly this time, is 0, and 3 times 6, which is 18. If you add 0 and 18, you get 18. Great job. And now for our last entry here, maybe I'll use brown if it works. For this entry here, this would be entry 2, 2, second row, second column. I'll be taking my second row of the matrix on the left with the second column of the matrix on the right. 6 times 2 is 12. 3 times 3 is 9. And 12 plus 9 is 21. So entry 2, 2 of the new matrix is 21. So the result that I'm getting is the 2 by 2 matrix, 12, 6, 18, 21. That is A plus B parentheses squared. It was in fact possible because we first were able to add the matrices since they were the same size by adding entry with entry, and then we were able to square the resulting matrix by multiplying it by itself. Because we had the same inner order dimensions, we were able to get a new product matrix using the outer order by carefully multiplying the correct row with the correct column to get each entry. I hope that was helpful for you. If you have any more questions about matrix operations or anything else in this unit, please feel free to contact me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.